Okay, so for this example, we have a parametric equation. Remember, a parametric equation is an equation where x and y are independent of each other. They're dependent each individually upon t. So we're trying to find the tangent line for x is equal to 3 cosine t and y is equal to 4 sine t at the coordinate t equals 3 pi over 4. Now that t value, 3 pi over 4, we're going to put that on hold. That is going to work after the derivative. We're not going to deal with it until we find dy dx. Then we will deal with that. But until then, it's just going to sit there. So, in order to get the equation of any line, we need two things, a slope and a point. To get the point, we don't have that. Usually we have at least the x value. Sometimes we have the full x and the y value. I don't have anything. I don't have anything that says x equals just a number or y equals just a number. However, I know x is equal to 3 times the cosine of t, and I know what t equals, so I can figure out my x value at t. And so we'll do that first. So I'm going to find x of 3 pi over 4 using that function. So x of 3 pi over 4 is going to equal 3 times the cosine of 3 pi over 4. Here's where your trig skills have to come into play because you're not going to have a calculator on your next test. So you need to be able to do this evaluation on your own. So cosine of 3 pi over 4, 3 pi over 4 is in the second quadrant. That means cosine is going to be negative. Cosine of 3 pi over 4 is negative radical 2 over 2. And so my x value is going to be 3 times negative radical 2 over 2, which means my x value is simply negative 3 radical 2 over 2. That's going to put on hold. We will utilize that when it comes to writing the equation, but for now, we don't need that anymore. Next, we're going to get the y value. To get the y value, we're going to utilize the same idea. We're just going to use the y function instead of the x function. And so in order to get my y value, y is equal to 4 times the sine of t. T is 3 pi over 4, and so I have 4 times sine of 3 pi over 4. Again, no calculator. You have to be able to do this trig on your own without a calculator at all. So, sine of 3 pi over 4, well, 3 pi over 4, that's in the second quadrant. Sine is positive in the second quadrant, and the sine of 3 pi over 4 is radical 2 over 2. And so my y value, when I multiply that out, is just 2 radical 2. We will put that on hold as well. So we have those two pieces of information. We have the x value and we have the y value. Now all we need is the slope. Once we get the slope, we're good to go. In order to get the slope, I need the derivative, but I need a specific derivative. I need dy dx. I can't get that right now because I don't have an equation that says y equals something with x's. So one of the suggestions that we had as we did this problems like this on the board and we did examples was to solve one of these equations for t, which is doable, but that means you're going to have say the sine of an arc cosine, and we don't know how to take derivatives of arcs yet, so that's not going to help us. So instead, we'll just take the derivative of each of these functions individually. So we have, again, our x function, x is equal to 3 times the cosine of t. We can take the derivative of that. When we do that, we want to be specific. We're taking the derivative of x, so that's dx, over the variable that we're using is t, so that'll be over dt. 3 is a constant multiple, so it stays there. The derivative of the cosine of x, we should know that. That's section 3-5. The derivative of the cosine, of t, not of x. The derivative of cosine of t is negative sine of t. And so, dx dt is simply equal to negative 3 sine t. That's not what I want, but it is a step to get me there, so I'm going to put that on hold. I'm also going to take the derivative of the y function. So I'm going to find the derivative of dy dt. So again, y is equal to 4 times the sine of t. I can take the derivative of that. When I do, I'm going to be finding dy dt, because y is the function I'm using, and t is the variable that's in that function. 4 is a constant multiple, so it stays there. The derivative of the sine of t, that's something that we should know back from section 3-5. The derivative of the sine of t is the cosine of t. No chain rule needed for that. Again, that's not what I want. I want dy dx, but it is something that I can use, so I put that on hold. So if you look, I've got my x value, I've got my y value, I've got dx dt, I've got dy dt, but I need dy dx. So we have this idea, this way that we work with fractions that we did on the board when we went through these problems. The fact that if I want dy dx, I can simply take dy dt and divide it by dx dt. If I do that, with the way fractions work, multiplying by the reciprocal and all that, if I multiply by the reciprocal, the dt's would cross out, I'd be left with dy over dx, which means that this fraction is valid. So, in order for me to get dy dx, all I got to do is take the two derivatives that I found and divide them. So dy dx is going to equal dy dt. Dy dt is 4 times the cosine of t. 4 cosine t divided by dx dt. Dx dt, we found, is negative 3 times the sine of t. Perfect. I now have dy dx. I'm just going to clean that up. Dy dx is equal to, we've got 4 over negative 3, so I'm just going to simply write that as negative 4/3. I have the cosine of t divided by the sine of t, which you could leave just like that, but me, I know my trig very well. The cosine of t divided by the sine of t, that's really the cotangent of t, and so I'm going to write it like that. There's the derivative that I wanted. It's not my final answer. I don't have the equation of my tangent line yet. I just have the derivative. But the derivative is going to allow me to get the slope. That's what I want. I need the slope. I have my coordinate. In order to get the slope, I can now plug in because I have dy dx, and so my slope will simply be negative 4/3 times the cotangent of t, which, as it has been, t is equal to 3 pi over 4, so I'm just going to be doing the cotangent of 3 pi over 4. Again, your trig's got to be good. You got to be able to do that without a calculator. So, negative 4/3 times cotangent of 3 pi over 4. Well, again, 3 pi over 4 is in the second quadrant. The cotangent will be negative in the second quadrant, and the cotangent of the cotangent of 3 pi over 4 is negative 1, which means that my slope is simply equal to positive 4/3. I now have all the pieces that I need. I have my x value, negative 3 times radical 2 over 2. I have my y value, 2 times radical 2. I have my slope, positive 4/3. That means I can write the equation of my tangent line, which I believe I can squeeze in right down here at the bottom, that my tangent line is going to be y minus my y value, which is up there in blue, 2 radical 2. That's equal to m, which is over there in red. M is positive 4/3. Times x minus my x value. My x value is up there in purple, negative 3 radical 2 over 2, and so the two negatives will make that a positive 3 radical 2 over 2. And there's my final answer, the equation of my tangent line with a parametric equation.